All right, let's start chapter 5. Chapter 5 is about polynomial equations. Um, uh, Basically, go back to chapter 4 and look at quadratic equations. Quadratics are a type of polynomial. Polynomial just means many numbers, more than one number. And what that's referring to is, say, for a quadratic, you have ax squared plus bx plus c. That's three numbers. And they're differentiated by the power of x. So for a polynomial that's different than a quadratic, you would just, go up in the greatest power of x. So in a quadratic, the greatest power of x is 2. You have ax squared plus bx plus c. You could have x cubed. So you could do an x cubed and an x squared and an x and then a constant. You could go to x to the fourth and so on. So you can see that relationship with the exponents means we should be familiar with exponents and the properties of exponents. So that's why 5.1 starts us with the properties of exponents. And in the intro video, I just want to make it possible for you to look at these properties and just think, totally, that makes sense. I get why that property is the way it is. And that's hopefully what you can do with all of these videos is I hope that through them you can look at the stuff in there and just say, oh, okay, now that just makes sense. Now I just know how to do it, but that makes sense. I know why that works. So you can go to the next video, the sample problems video, and just see how to use it, but we're going to go into the why here. So the first property, called the product of powers, says a times n times a, or a to the m times a to the n equals a to the m plus n. So it's just saying if you have something raised to a power and you have the same thing, what we call the base, a is the base, the thing you're raising to a power. If you have the same thing again, you're multiplying them together, you add the components together, you add the exponents together. So just a quick example, what if we had 5 squared times 5 to the third? Okay, how could we simplify this? The reason why it winds up being the way that it is, and it just kind of will help us see that it makes sense by doing this. 5 squared means 5 times 5. Then we're going to multiply that by 5 to the third, and 5 to the third means 5 times 5 times 5. And so altogether, that's 2 5s, and then we have added to that another 3 5s. And if you multiply 5 by itself 5 times, that's 5 to the fifth. That'd be the same as taking 2 plus 3, that's just 5. So you can see you've got m of these a's here and n of them here, and you're just multiplying this long string together of all these a's. There's m of them and n of them, so together there's m plus n of them. All right, so something that is closely related but slightly different, a to the m. This is the second property. This is the power of power. If you raise a power to a power, how do you combine those powers? We're going to do this often. It's multiply the powers together. Why is that? So let's look at 5 to the second raised to the third. So here we're doing 5 to the second times 5 to the third. Now we're doing 5 to the second raised to the third. What does it mean? Okay, it means this. First, let's look inside the parentheses. 5 squared means 5 times 5. Okay, you raise that to the third power. What is raised to the third power? It means whatever you're raising to the third power, multiply it by itself 3 times. So 5 times 5, okay, that's once, times 5, that's twice, times 5, that is 3 times. You got 5 times 5 multiplied by itself 3 times. You have 3 groups. Each of the groups has 2 5s. That's, if you remember from elementary school, most often we phrase multiplication just like that. Groups of, 3 groups of 2, that's multiplication. So if you raise a power to a power, you're going to have this many groups of this many of these. So you'll have this multiplied by itself, 2 times 3 times, 6 times. So this would be 5 to the 6, because it's 5 times itself 6 times. That's the same as 2 times 3, that's 6. Okay, let's go to the next. The power of a product. A times b to the m is the same as a to the m times b to the m. The reason I want you to be able to make sense of it, every time I look at a problem, personally, or even a word, or just so many things that I want to understand, I like to have it make sense. Like the meaning of a word. If you look at a word, you break it down into its keywords and the different parts, and you understand what certain prefixes mean and suffixes and all this different kind of stuff. It just makes more sense. I understand this more thoroughly, understand more of why this is. It's the same as this thing. It's like it's a word and it has a meaning, and we want to understand its meaning by it just making sense. So, why is this? And like a big thing, a big reason why I would like you to understand why is because something that gets thrown around because it looks so similar is distribute. I'll just distribute the m to both of these. I don't like to use that word distribute because this is not the distributive property. And though that word distribute is appropriate because technically that is kind of what's happening. But it's so easy to mix those things up. So just be careful about that. It's not the distributive property. And if you start using that word, you easily confuse yourself. Why is it that this m can be given to a and to b? Why is that the same as this? Let's use an example. Let's do 5x. That way we won't be tempted to try and put them together. Like if I did 5 times 3, you'd just want to multiply those two numbers together. So let's do 5 times x, and we'll do it to the third power. And we'll see that in the end, we wind up getting 5 to the third times x to the third, which is 125x to the third. And why is that? Well, what does this mean? Let's start with that. What does raising something to the third mean? It means multiply it by itself. So 5x times 5x times 5x. Multiply it by itself 3 times. Okay, so there's this property called the commutative property. We can move these things around since they're all being multiplied in any order that we want. So we will choose this order, 5 times 5 times 5 times x times x times x. 5 times 5 times 5 is 5 to the third. X times x times x is x to the third. And there you go. And now you can hopefully extrapolate that to any problem. If this is a number times another number and it's raised to the m, we're just going to take these two numbers, multiply them by each other m times, rearrange them. You get m a's and m b's. And that's exactly why it comes out like that. Okay, let's move to a negative exponent. So this is a weird kind of a thing. And I just want to, maybe we will use this in conjunction with another property. Okay. So there's this property of negative exponents. Let's come back to this actually, after we get done with the fractions part of this. So let's actually jump down to the quotient of powers. We'll jump down, if you're looking in your book, at the order that these are in. So let's do a to the m over a to the n equals a to the m minus n. And why is that? Right, and we're going to use the same kind of reasoning as we did up here when we multiplied two numbers together. Now in this next one we're going to divide them, but we multiplied two together and we added their exponents. Now we're dividing and subtracting. Divide and we're subtracting their exponents. So let's just use a specific example and hopefully be able to extrapolate out to the general. So let's do 5 to the 4th. Let's do 5 to the 5th over 5 to the 2nd. Okay. So in the end, we should be able to just say 5 to the 5 minus 2, or 5 to the 3rd. And why is that? Well, let's just say what's 5 to the 5th mean? It means 5 times itself 5 times. And down here we have 5 times itself. And now what could we do? Well, we have common factors that we could cancel out. We know that we've worked with fractions long enough. We can cancel out common factors. So this 5 divided by 5, that cancels each other out to 1. This 5 cancels with this 5. And now what do we have left but just 5 times 5 times 5? Right, that's 5 to the 3rd, which is 5 to the 5 minus 2. You can imagine that could be the case for any fraction where you have the same bases, where this is, if this is 7, also this is 7. You could write out all the factors, they would cancel each other out. Okay, so let's use that, and we'll talk about this negative exponent thing. Let's accept that this subtraction is a property that makes sense, it's legal. So what would happen if maybe we flip this over? What if this was 5 squared over 5 to the third? Let's just accept this as a property and we'll apply it. That's 5 to the second minus 3, or sorry, this should be to the fifth. 5 to the second over 5 to the fifth, that's going to be 5 to the negative 3, right? If we were to write this out, we would see it would be 5 times 5 over 5 times 5 times 5 times 5 times 5. These two would cancel each other out, and we'd just be left with 1 over 5 to the third. Okay, so you see how 1 over 5 to the third is same as 5 to the negative 3. And it's just kind of a consequence of the way we have decided to write numbers. This negative exponent just is an expression of, a different expression of this number here, 1 over 5 to the third, or you could do 5 to the negative 3, because you can see how it works out the way we've displayed it here. The same thing for 5 to the 0. Here's a weird one. Or something to the 0. So a to the 0 equals, what would you think? There's 0 involved, and exponents are closely tied and linked with multiplication, so you might think it's 0, but it turns out to be 1. That's a weird thing. And why might that be? Let's work our way up to it real quick here. So let's do 5. 5 to the fourth over 5 squared. What's that going to be? That's going to be 5 times 5 times 5 times 5 over 5 squared, or 5 times 5, excuse me. So this 5 cancels that 5 cancels. We have 5 squared. That would be 25. Okay, let's do 5 to the third over 5 squared. That's going to be 5 times 5 times 5 over 5 times 5. Cancel. And we're just left with a single 5. Now let's go to 5 squared over 5 squared. We're left with 5 times 5 over 5 times 5. These cancel each other out. What do we really have here? We have 25 over 25, right? One thing divided by the identical thing, or divided by itself. That's 1. Let's look at it another way. Let's apply the property of a quotient of powers. Let's subtract these powers. That's 5 to the 2 minus 2. That's 5 to the 0. Okay, 5 to the 0 is just, you could imagine it as a representation of, or a result of having a fraction like this, where the powers are the same, they're identical. So you subtract them, they go to 0. And if you have identical powers, you have identical numbers. This is 25 over 25, which is the same as 1. Okay, so just an example of why in the world would something to the 0 be 1 rather than 0. All right, so it's the property of a 0 exponent. And the last thing is, if you have a fraction, a over b raised to the m. My a's always wind up looking like 9s. So this is going to be a to the m over b to the m. A gets an m exponent and b gets an m exponent. Okay, why would that be? And they can be any two numbers. Let's do 3 over 5 and raise that to the 4th power. Okay, so what does raising something to the 4th power mean? It means multiply it by itself 4 times. And how do we multiply fractions? We multiply straight across. When we multiply 3 times 3, then we would get that. We multiply that by another 3, and then we multiply that by another 3. So we'd have 3 times itself 4 times, and the same in the denominator. We'd have 5 times itself 4 times. So you can imagine that the general case would just be this fraction times itself m times, which means we would multiply the numerator across m times, and the denominator m times, and so that's why we can just give this m to the a and to the b. Okay, and these will be it'll be important for us to understand these properties, to be able to use them, to wield them at will, and to wield them with ease. Okay, so I thank you for watching and trying to make this a little more intuitive, be able to understand this a little more. Okay, hold on. I just wanted to add one more thing in regards to negative exponents. I would add this as one more property of negative exponents. Okay. So if we have a over b to the negative m, we could use this quote shortcut to write it this way. Okay. And now I want to show you why, make it more intuitive as to why this happens. Why can we just take the reciprocal of the fraction and then make the power positive? Let's say we have 5/3 to the negative 3. Okay, and I'm going to use properties that we've already established. So I'm just going to give this negative 3 to the 5 and to the 3 separately. So 5 to the negative 3 over 3 to the negative 3. Then we have properties of negative exponents. 5 to the negative 3 is just the same as 1 over 5 to the positive 3. And we already talked about why that is. Okay. Good. And then we have a fraction divided by a fraction. Whenever you divide by a fraction, we should be familiar with, instead of dividing by a fraction, multiply by the reciprocal. So 1 over 5 to the third times 3 to the third over 1. Right, multiply by the reciprocal of 1 over 3 to the third, which is 3 to the third over 1. And so now we have 3 to the third over 5 to the third. Okay, and that is the same as 3 over 5 to the third. So we took this fraction to the negative exponent and turned it into the reciprocal to the positive exponent. Okay, so that's going to be a useful property, a useful thing to do. You're going to raise something to the negative exponent, just flip the fraction over and raise it to the positive power. Okay, and one other related thing, and I wouldn't count it as its own separate thing. It's kind of what we saw here. You know that, for instance, 5 to the negative 2 is the same as 1 over 5 squared. Okay, so, what if we had 5 to the negative 2 over x? Well, that'd be the same as, if you needed to, 5 to the negative 2 times 1 over x. 5 to the negative 2 is 1 over 5 to the positive 2. We're still multiplying that by 1 over x, and so we get 5 to the positive 2 over x, or times x. So all that really happened was this thing with the negative exponent came down to the denominator. Shouldn't be too surprising, because we know the property of negative exponents says that this should, this is the same as 1 over 5 squared. What if we had x to the positive 2 over y to the negative 3? What would we do with this negative 3? Well, we know that y to the negative 3 is the same as 1 over y to the positive 3. We're dividing by a fraction, so let's multiply by the reciprocal. We get x over 1 times y to the third over 1. That's the reciprocal of 1 over y to the third. And now we have x, y to the third over 1. So all that really happened was the thing that was in here in the denominator that had a negative exponent, it came up to the top. So it would be kind of hard to express that as a property. Right, but it's just really a consequence of negative exponents. If it's in the numerator and it's got a negative exponent, move it to the denominator. If it's in the denominator and it's got a negative exponent, move it to the numerator. It's just, it's a little more complex than that. It should require a little more reasoning, but in the end, that's just what happens. So just remember that if you've got a factor down here that has a negative exponent, move it up to the numerator. And vice versa. If it's in the numerator, move it down to the denominator. So that was just something I wanted to talk to you about real quickly at the end here about negative exponents. Thank you for continuing to watch.